again. All right, so we're going to do some calculations. So again, here I have a graph with some outliers and maybe a couple of different lines or a curve flowing through these points right here. If I'm curious, like, is there a relationship between the alkalinity of a lake, and alkalinity is a different measure than pH. It measures how resistant the water is to being acidified. So I want to do alkalinity here versus, so that would be my x, and where's average mercury over here. So I'm going to copy those and get them into stat key. To do that, I need to make a new sheet and get them next to each other. So I'll show you how to put data in the stat key and then how to do the same things in a spreadsheet.
You can't just hide cell columns DEF
I
and
don't
copy and
think,
paste
that's
that
a
way.
good question. I don't think you can, but I could try that. Let's try it just to see. I know that other way works, so I was just being overly cautious. So what if I hid those columns? Where's hide? Is that under view? Format? Did I miss it somewhere? Sorry, I'm a little slow today.
I always just use the right
It's in, I can just
function
right
on the
click on
mouse.
them.
Yeah. And then hide columns D through F
Hide
there.
columns, thank you, there we go. All right, so what if I highlight, and again, when you copy into stat key, don't highlight the whole thing, because I think stat key might freak about all those empty cells. So I'm usually a little more cautious, and I'm just gonna go to the bottom of the list and then copy. Let's see if this works. Stat key. So from any of the data on the two quantitative variables, you just click edit and delete their data. They have their points separated by commas. If you look there in Excel, when you copy and paste, or sheets, they come in as what's called tab or space separated. And it grabbed all of them, even the hidden ones. Okay, yeah, so that didn't work. So to get them in the stat key, I had to get them physically next to each other here, and then I can copy them and put them in. And does my data have a header row? Yes, it does. So I leave that checked, and then it makes the graph. So here's the same graph I had Sheets make a minute ago, and it's showing me the line. So that's one cool thing about stat key. You throw your numbers in there, and it does all the calculations you need. And the ones we need are, how many numbers were there? What's the correlation coefficient? R, what's the slope? What's the y-intercept? So stat key calculated all that stuff for me so I could write it down. Now, if I want to use those numbers, I got to type them into a spreadsheet or some other calculator. So it's worth doing in a spreadsheet too, but this is a quick way to do it. Now for this data set right here, remember those 3 questions I asked earlier? Let's go back to those right here. Do you see some trend to the plot? Yes, I do. Does the plot, does it seem to be linear? The answer is, well, no, it doesn't. In other outliers, the answer is yes. So I don't think I want to proceed with finding a linear model. Okay? I don't know how to find nonlinear models at the moment, so I'm just done with it. So I'm not even going to continue with that one. My point with that example right there is those 3 questions, it doesn't satisfy them, so done. Let's take...
See, it's interesting that this is one that you wouldn't do, but yet when we looked at the correlation number, it's actually higher than that last one you showed.
So I know. Yeah, so that's a good point there. Again, we can't just rely on correlation. And if you read the book, it talks about cautions about the value of the correlation. Now, we have to look at the graph too. So on this one right here, I see a curve going on that I tried to make a picture of here. Let's go back. So this green curve is what I see going on here. So I see it swooping down and then leveling off. So it's steep over here, but it's shallow over there. And then we have those 2 weird points there. So just right there, even though the calculation of correlation leads to something that's not too bad, it's in the middle of strong and weak, because I see the curve, I'm done with it. I keep hitting the wrong button, there we go. Versus if I look at the original mercury versus pH there, I don't really see a curve there, but it is pretty cloudy. No points jump out to me as outliers. So somebody might look at this and say, well, we really should do some more research to see if this is really a good correlation coefficient. And there are other ways to test that, but again, that's beyond the scope of our course. So it could be we look at this and say, nope, too cloudy, done with that. The restaurant versus tip one, however, that's relatively tightly packed. There's a few outliers, but there's a lot of data here, relatively 157 points. So I could take this data right here, put it in a spreadsheet, and play with it some more. So I just want to take a different data set and play with it in StatKey. So let's see, what do I want to look at? We have our survey. Yeah, I'm kind of curious about this one right here. So I'm going to reshare this to the chat for anybody else that wants to check it out. But you should have if you were in class last week or the week before, you should have the link to this. I think I hit copy, didn't I? Yeah. And then chat. And everyone. Okay, so in the chat should be the link if you want to play with this spreadsheet with me. And then I was thinking of looking at, I didn't write it down. Hours of sleep versus hours of TV, maybe? Hours of work versus hours of TV each day. Hours of TV versus hours of schoolwork.
Hours of sleep and hours of work.
Hours of sleep and hours of work. Okay, and they're right next to each other. All right, so I'm going to copy those two into a new tab. So to do that, I'm just going to highlight just the data. We've got some blanks to contend with. Oh, interesting. There we go. So I'm going to copy that. New tab. And so this is work versus, actually it's sleep versus work. Usually we put the Y variable first versus work. So I'm thinking about, and paste that in there. And then I think I want to sort, do we have, how many blanks do we have? Just that one at the bottom. Just that one for sure. All right, so just to make sure, I think blanks are treated as zeros when we try to graph them. So data, let's do two different sorts on this just to double check. Sort first by sleep. And there's only that one blank, so I'm just going to delete that. And then just to make sure I didn't miss anything, sort again, but by the other variable, work. And okay, so I got all the blanks out, and then hopefully there's no weird outliers. We'll see in just a minute. And then let's see, which one do we want to be the response variable and explanatory variable like X and Y? I'm thinking of maybe work might dictate how much you sleep, so switch them.
Yeah, I think so.
Let's cut that one, put it here, and then just get rid of column A. Just delete. There we go. Okay, so then we just highlight it all and we make a scatter plot. So before we do calculations, we should look at the graph and whoa, check that out. What do we see? Cloud. I think I see a slight downhill trend that as someone works more, they sleep less. But it's pretty damn
You think
common.
it's because it's a predominantly students that were surveyed?
Yeah, so this is a very biased sample for sure. But let's go a little farther. So let's make some calculations. So let's say, okay, maybe there's a trend. Let's take a look. So do I see outliers? This point seems a little odd compared to the rest right there. Otherwise, I'm not sure. Calculating outliers with multivariables is a little trickier. So here's what we're going to calculate next. We're going to find the value of, let's go over here, R, the correlation coefficient. And then we can also find the slope and the y-intercept. Okay, so remember, what is R? It's the correlation coefficient. So if I go equals and I start typing the word correlation, C-O-R-R, it says correl, which is short for correlation, Pearson product moment correlation coefficient. Yes, that's what we want. So I select that. It says, okay, select your Y's first, okay? So my Y's are in the second column. So I highlight my Y's, comma, and then it says now highlight your X's. So I'm at the bottom of the list. Let's go to the top. And I get, I don't want to fill it down, a very small value. So what does this tell me right here? Two things. There's a negative association, and it's weak, right? And again, when I was looking at that graph, I'm thinking, I kind of see a downhill trend, but it's pretty weak. So do we continue to find the slope and the y-intercept? No, we're done with that there. Okay, let's try something else. So let's see. I had one with the United States I was looking at. Percent college versus household income. Now, next class, I'll show you how to make bubble charts. They're kind of cool. I'll explain that later. But for now, I just want to use the college and household income. And I'll explain those variables. Let's get them in a new sheet and then I'll share it. All right, because this one I saw a bit more of a trend when I was looking at it earlier. Let's see, anyone with a link can view. Yes, please. And I'll throw this in the chat for anybody that wants to play with it. And this is the US states data that came with our textbook. So I just pulled it from their website. And there's the link if you want to jump in there. Now, I grabbed the name of each. I didn't need to. And again, I could put this in the stat key too, but again, my point here is to show you how to do it on a spreadsheet. So first I'm going to look at a graph to say, okay, is it worth even continuing with this? So we just do a visual inspection first. So graph, and it made a scatter plot. Okay. I see an uphill trend there. There's a little bit of scatter, a little bit of cloudiness going on, but it looks like an uphill trend. Now there's all this empty white space underneath, so I think I'm going to get rid of that to see if it enhances the trend that I see there. Sorry about that black box there. So that would be, let's see, vertical axis, and then maybe set the minimum to 30. See what that looks like. Sorry, my zoom buttons are in the way. Yeah, I think I see an uphill trend there. So looking at that, I'd say, all right, let's find the correlation. So I'm just going to move this up here, say, and then give myself a little space, say right here, I'm going to find the correlation, and that would be equal correlation. Highlight your Y values, comma, and then the X values.
Do you remember what that college number means?
Oh, sorry, I forgot to explain the ones. Yeah, so this is the percent of people in the state with college degrees. So in Alabama, 24.9% of people have a college degree. Colorado, 37% of people in Colorado have a college degree, and so on. Yeah, so let's get a better description of that. So college is, maybe I should write percent with college degree. Yeah, so I had to look that up earlier, and that in the back of the book, they talk about those. And then household income, this is in thousands. So household income in thousands of dollars. So 43 for the, it's average household income. Let's put that in there. Average, thank you for asking about that. So average household income in thousands. So 43 really means on average in Alabama, people make $43,000 a year combined in the household. Alaska, 70,000. It's more expensive to live there, I guess, and so on. Okay, so what do we get for R over here? We got R is 0.685, which means it's positive, right? Uphill. So that tells me I have a positive association. Positive association, and it's above 0.5, so let's say relatively strong. It's not really strong, right? It's not near 0.9 or 1, so we'll just call it relatively strong. Okay, so all right, there's a reasonable correlation, so let's go find the slope and the y-intercept. So if we then say equal, oops, no, make a note, m is what I'm finding next. All right, m equals, and over here to find the slope, you just type slope. And it says, oh, okay, where's your y numbers? So I say, here are my y numbers, comma. Then it says, okay, where's your x numbers? X numbers, oops, but not the title. There we go. And by the way, when you do put in the x and the y, there's got to be the same number of rows or columns for x as y. So it doesn't have to be column-wise. It could be row-wise. And it could be in blocks of numbers. It doesn't have to be in a column or a row. All right, so slope is about 0.9. We'll go over that in a minute. And then the y-intercept, we call B, right, is just called intercept. Y-intercept for linear regression, which is what we're doing. So it's a little more work to get this in Sheets than StatKey. I got to type 3 formulas. But I can then use those formulas a little more easily. And just to compare this, I must have done something wrong there. Oh, it says I have the, I don't match, right? I highlighted a different amount of numbers. So it should have been from B2. I clicked in the wrong spot. There we go. And the y-intercept's about 22. It turns out that on the graph, you can actually get all of that or some of that information up here. So if I go to the graph here and I choose edit, customize, and then series, I can do trend line. So there's the line that I found, same one StatKey would find. Change the color if I want. I'll make it red like StatKey does. And then for label, I can say, hey, use the equation for the label. So here it's saying the slope is 0.98 times x, right? 0.98 is the slope. You can see that number up here in SLH2. And the y-intercept's about 23.1, which if we rounded b to the nearest 10th, we get 23.1. So I don't necessarily have to use the slope and intercept functions. I could just ask the program to put them on the graph. And it'll also give me what's called R squared. Now notice this is R squared versus R up here. So that's a different calculation, but I can quickly get it on the graph. And I want to talk about R squared. I guess I have to since it's here. The book does not talk about it, I don't think, till chapter 9, unfortunately. It's 0.47. If I were to square this 0.68 number, I would get 0.47. So just side note, R squared. If I go equals this guy raised to the second power, there's that 0.47 that they're displaying on the graph. Or if I went the other way around, if I take the square root of that number, so R equals square root on a computer is SQRT, and then I type 0.47, the number on the graph, it's going to say, yeah, it's about 0.68-ish, 0.685-ish, right, which matches this number over here. So on the graph, You can get R squared, but not R, but you can get the slope and the y-intercept. R, remember, is the correlation coefficient. R squared is called the coefficient of variation. And it is not the correlation coefficient. It tells us something else about the data, which I don't want to get into right now. But just note, if you do ask on the graph about R, it won't tell you R, right? The only option it gives you is to find R squared down here. So normally in this class, I don't click that, but how can you resist it? It's got an R, we're talking about an R, but notice it's a square, not the regular R. Okay, now other things I can do with this. So then somebody could say, okay, well, you know, there's places that aren't on here, like I'm going blank now. What are some territories of the US? Puerto Rico, right? It's not a state, it's a territory, but it is part of the US. So I wonder if we knew the percent with college degrees in Puerto Rico, would that allow us to predict the average household income? Okay, so could I use this equation to make predictions about places that aren't on here? Or maybe could I take, like a lot of people think Eastern Oregon is a different state than Western Oregon. Could we just isolate Western Oregon and look at percent college degree there versus household income? Does it fit this trend? The answer on those questions is maybe. We have a reasonably high correlation coefficient, which means it's kind of safe to use this equation to make predictions. So what does that mean to make predictions? So let me copy this and explain. And let's see, I think I really only need that much for now. So based on the spreadsheet, and StatQ would give us the same information if we asked it. Because this correlation coefficient up here it says we have a reasonably strong correlation, or relatively strong. Then we can graph the line and it might be meaningful, right? A line has an equation y equals mx plus b. In this case, y is the average household income in thousands of the state, and x is the percent of people with college degrees in the state. And so we think the equation is y equals about 0.98 times x plus about 23. And then suppose somebody comes to us and say, hey, we have this almost state place, like let's say Puerto Rico. And now I'm just going to make shit up for a second. And let's suppose that we knew, and that this is not true, I didn't look this up ahead of time. We knew that in Puerto Rico, about 20% of people have college degrees. So X is about 20. If we then plug into this equation, y equals 0.98 times X equals 20 plus 23, then we're going to get out a number that might estimate the average household income. So let's calculate that here. So suppose here I say, okay, let's let y equal 0.98 times 20 plus about 23. So I'm just rounding those numbers for ease. So 42.6. So this equation predicts that if the percent of people in a region with college degrees is 20%, that the household income should be 42.6 thousand. So what does that mean? If a region has 20% of people with college degrees, then we predict an average household income of about 42,600. Right, so we can take the given information and then make a prediction. Now, this prediction I made about 20,000, if we look at the graph, or 20%, excuse me. Let's see, that's 25%, that's 30%, so 20% would be over here. So there were some states that had around 20, right? There's a 21. I wonder what the minimum was here, kind of curious. Okay, so 20 actually is a little below. It's not within the data set. If I pick a number that's within the range of data, that's called interpolation when you make a prediction. Since the X value I picked, so this was right here, was based on X equals 20. Since 20 actually isn't in the range of data, this would be called extrapolation. Extrapolation. However, if I did it for something like X equals, let's suppose we knew a place had 30% of people with college degrees, then we could calculate Y, the household income, by just taking the slope, 0.98, times the percent, 30, plus the y-intercept, about 23. And so we get an estimate of the household income, on average, about 52,000 a year. Since that X value is within the range of the given data, that would be called interpolation. And I'll define those in just a minute. So I can make predictions with using numbers that are kind of within the range of the data I started with, which means between the mins and the maxes. Extrapolation means you pick a number X or Y that's outside the mins or maxes. So again, I'm extrapolating here. And that's since X equals 20 is outside the range of the data. If you have a strong correlation coefficient, which mine's relatively strong, it is safe to interpolate. Extrapolating is a whole nother thing, and that can be dangerous because it's outside your range of knowledge. My range of knowledge is the given data. Oops. So making predictions. We have two ideas: interpolation, which is to predict within the given range of data. And then we have extrapolation, which is to predict outside with the equation. Interpolation is safe if the correlation is reasonably strong. Extrapolation is dangerous if you move too far away from the data. Because we just don't have any knowledge about it. We would need to collect more data. Say, hey, are there any data that are out in that range we didn't have originally? We go look for it. Now, sometimes data is time-based, like the future, right? A year. So can we make predictions about future years? The answer is yes, but the further out we look, the less likely our predictions are correct because stuff happens. So in this case, when I chose 20 as my percent, 20 is not too far away from the edge of this data set. So yeah, that's a reasonable extrapolation there. And then my interpolation here is, well, there are several states that had around 30% people with college degrees, but they had a pretty wide range of, we click on them, they'll tell us 46,000 down there, 67,000 per year up there. So there's a kind of a wide range of what's going on out there. So even interpolation can be dangerous if you don't have a strong enough correlation, and then it depends on how you're using it, right? Does this predict reality? The answer is no. Does it estimate reality? The answer is, well, yeah, to a reasonable degree. Measuring that degree is a whole nother matter that comes up in chapter 9, which fortunately we don't have time to do. So we're just kind of scratching the surface. And the big ideas here are, given two quantitative variables, can we make a scatter plot, look at the scatter plot and say, do we see a trend? If the trend appears to be linear and there's no big outliers, then we try to find an equation. And StatKey can find the equation, or Google Sheets can find the equation for us, or Excel can find the equation for us. And then we can use that equation to make predictions about things. So we'll stop here today. Next class, we're going to do pretty much the same stuff. I'll review the idea of what does correlation mean? How do we use it? What do we do with the models that we find, which are the equations, and working with predictions? And then we'll take a little bit of a look of the idea of what are outliers in a data set and whether we should remove them or not, and how do we measure, at least not as detailed as measuring outliers in the last section, but we'll scratch the surface on it. And then after that, we'll look at some interesting other kinds of visual displays of data for multivariables. So let's stop the recording for a moment. Oops, what did I do? I stopped the sharing.